Section 9.4 is on adding and subtracting rational expressions. The first step in doing this is to find a common denominator. And it's been a little bit of time since y'all did common denominators, so let's just refresh your mind. You're looking for the smallest number that both the 7 and the 11 can go into. Those are the denominators. The smallest number that both 7 and 11 can go into would be 77. So I'm going to rename those with 77 on the bottom of the fraction. So I look here and I go, oh, I'd have to multiply the top and the bottom by 11 here to get 77 on the bottom. So on the top, I have a 55 over the 77. Over here, I would have to multiply by 7 to get a 77 on the bottom. So I have a 56 on the top here. Well, when I add those, it's going to give me 111 over 77. And so you would make a common, you would probably make a mixed numeral out of that. It's going to go one time if you remember the whole mixed numeral thing. Let's see. And it's got 34 left over, so then I would have a 34 over my 77. So that would be my answer to that question. Let's do this one. Common denominator between 4 and 6, the smallest number that both 4 and 6 can be divided into would be 12. So I'm going to rename both of them with 12 on the bottom. So I go 4 times 3 equals 12. What I do to the bottom, I also have to do to the top. So this fraction 3/4 gets renamed as 9/12. I would have to multiply 2 times the bottom there. So I multiply 2 times the top. And that's going to give me a 10 over 12. So this one gets renamed as that. Then, of course, when your denominator is the same, you're going to add your exponent, or the top numbers, or your numerators. So I get 19 over 12, which is 1 7/12. All right, but that's just a little refresher, because what you're going to do here is you're going to involve variables, and you're going to find the common denominator. So let's start with this one. I look at the 5 and the 3, the coefficients, and the very first thing I do is I go, what is the smallest number that both 5 and 3 can go into? And it would be 15. So I know 15 is going to be a part of my common denominator. Then I look at the variables and I say, what is the highest power of every variable that's represented there? The highest power of A is a squared, so that's going to be a part of our variable. Highest power of b is b cubed, so that's, there we go, so that's our common denominator. I'm going to rename this by looking and saying, how can I turn this bottom into this bottom? So I would have to multiply it by 3a. What I do to the bottom, I also must do to the top. So that's going to give me a 6ax on the top. Over here, I'd have to multiply by 5 and by a b to make it match that bottom. So that's going to give me a 20 by. Now I could rewrite it like this: 6ax plus 20 by, and it has a common denominator, so 15a squared b cubed. All right, let's practice a few more of them. Looking for the common denominator here, the smallest number that both 10 and 5 can go into would be 10. Okay, so I know that's going to be part of the common denominator. And then I have an a, so both of those will need an a. And I have a b, so both of those will need a b. So that's going to be the common denominator, the number that I could turn either one of these bottom numbers into. This one here, if you notice, is missing a b, so I multiply the top and the bottom by b. That's going to give me 9b. This one is missing an a, so I multiply the top and the bottom by a. That's gonna, oh, and it's also missing a 2. So that's going to give me an 8a squared, and then of course on the bottom that would give me 10ab. So I could rewrite this as 9b plus 8a squared over 10ab. All right, this one, common denominator, the highest power of x I have is an x squared, so I'll put that in there. And the highest power of y I have is just a y. So this one is actually not missing anything, so if you will, I multiply it by 1, so I put a 2 right there. This one is missing an x, so I multiply the top and the bottom by x to make it so I have x squared y on the bottom, so I have a 2 minus x, so I could rewrite it as 2 minus x over x squared y. All right, so those are somewhat the simple ones. Then they get a little bit more complicated. Now, if you'll notice, everything that we've had up to this point has been multiplied together on the bottom as a denominator. There hasn't been any plus or minuses in the denominator. So now we come over here and we have a bunch of pluses in the denominator. The very first thing that we're going to have to do is we're going to have to factor these, because we want to get to a point where we have just a bunch of parentheses that we are multiplying together. Okay, so I'm going to factor this first one. So I'm going to bring this down here, and I have x plus 2 and x plus 3. That's what this factors into. Then I'm going to factor this one. I have x plus 2 and x plus 2. Now, I cannot separate out numbers within one parenthesis. If I am going to take a parenthesis, I've got to take the whole thing. I have to look at the whole thing together. I cannot look at the x and the 2 separate. So I look here between the two denominators, and I notice that they have an x plus 2 in common. So I'm actually going to mark out the x plus 2 they have in common, and then my denominator is going to be made up of what they have in common times everything else that's left up here. So x plus 3 has to go down in the denominator, and another x plus 2 has to go in the denominator. Now I could write 2 of them out. Maybe that would be easier. All right, so I'm going to turn this one into this. So I go, that's got an x plus 2 and it's got an x plus 3. So what I'm missing is an x plus 2 to make it match that denominator. What I do to the bottom, I also have to do to the top. So I have to do distributive property here, because I'm going to take x times x and x times 2. So I have x squared plus a 2x. Then I come over here and I go, well, this one is missing both an x plus 2 and an x plus 3. So I'm going to have to multiply the top times the same thing I'm multiplying the bottom by. Now you know you're not really technically multiplying the bottom. You're just making sure it matches the denominator. So I come over here and I go, oh, I'm going to multiply, and I think I'm going to go ahead and add the opposite and make that a negative 2. And I'll go ahead and do FOIL on that. It's going to give me x squared plus 5x plus 6. Okay, now I'm going to have to distribute that. So I have an x squared plus a 2x minus a 2x squared minus a 10x minus 12. And it's over top of x plus 2 times x plus 2 times x plus 3. I still have to combine like terms here. So it's going to give me a negative x squared. I've combined that one and that one. Minus an 8x minus 12. over x plus 2, x plus 2, and x plus 3. Now, the question would be whether I can factor this top, because if I can factor it and it eliminates out here, I'm required to do so. So give me a second, let me see. Experiment for a second. It's not going to factor into anything that would eliminate out. Well, no, maybe it would. Let's see. I had x and negative x, and I had 6, and I had 2. So this would have to be positive, and that one would be, no, they'd have to both be negative, which then we can't get that. So that's going to give that a negative. If I switched them maybe. That's still going to give me, that'll give me 2 positives. Okay. That negative in front is the problem. Okay, so let's go, let me back up here again. That would have to be negative right there. So that's a negative 2. And this one would have to be, well, but that's going to make that a positive. That could be a positive 2, but then that's going to give me a and then I can make this a negative 12. I think that will work. Okay, or negative 6. Okay, because then I have a negative times a positive, which gives me a negative. Okay, so the whole reason for doing that is because now I can cancel out one of those. So my final answer is just those. These are intense, okay? You'll have to stick with them. Do one step at a time. Let's do another one of those. All right. So the first thing I'm going to do is I'm going to factor, okay? So I'm going to factor that first one. So I'm going to factor it into, let's see, a 2a, a 2a, and a 1 and a 1, and they would have to both be negative. Now notice that that is very similar to this one. So what I can do over here is I can factor out a negative 1, and that's going to give me a 2a minus 1. Okay, so I have 1 minus a. Now if I don't want to mess with a negative 1 on the bottom, I can go ahead and distribute it to the one on the top. So I'm going to do that. So I still have 1 over 2a minus 1, 2a minus 1. But now on the top I have a negative 1 plus a. So I just took that negative 1 and distributed it up there. So then I have a 2a minus 1 here. Notice what it is missing. Common denominator would have to be 2 of those. So I'm going to have to multiply top and bottom by 2a minus 1. So on the bottom here, I have 2a minus 1 times 2a minus 1. And on the top, this one's not missing anything, so I bring down the 1. This one, I'm going to have to do FOIL on. So first is going to give me a negative 2a. Outside is going to give me a plus 1. Inside is going to give me a 2a squared. And last is going to give me a negative 1. So then I can combine any like terms that I have. I've got a 2a squared. I've got a negative 3a. And I've got a plus 2. Okay. and it does not come out whole, so you can't do a thing to that. You can't factor the top, so you're just going to leave it like that. Alright, let's come over here. The only thing I can do on these is I can factor out a 2 here, so I have a x minus 3, and on the top I have an x minus 5. This one I can factor out a 4, and I'll have an x minus 3, x minus 7. Now, common denominator, take what they have in common, so an x minus 3, and then I have to look at the 2 and the 4, so I could put a 4 in front of that, and that would be my common denominator, because the smallest number that 4 and 2 can divide into is a 4. So this one right here is missing a 2, because I've got to be able to make that 2 into the 4. So I'm going to multiply 2 on the top and the bottom. So that gives me 2x minus 10. This one over here is not missing a thing, so I still have to distribute my negative, so it's minus x plus 7. So when I put these things together, I've got x minus 3 on the top, because 2x minus x, and then negative 10 plus 7, and it's over 4 times x minus 3. So these two will eliminate out. Now remember, you can't break them up, but if the whole thing will eliminate out, you can do so. So I'm left with a 1 over 4. You've got to have the 1 there so that you know that the 4 is on the bottom. All right, let's do a couple more. If you'll notice, these almost match, but there's no, I can factor out a negative here, and it's not going to make it match exactly. So my common denominator is going to have to be a combination of those two things. So that I make the common denominator by multiplying them together. So this one is missing an x plus 2, and this one is missing an x minus 1. Obviously what you do on the bottom you have to do on the top, so I just wasn't showing it. Okay, so I'll do distributive property or FOIL here, so it's going to give me x squared plus a 4x, because I'm going to do outside, which is 2x, inside, which is 2x, and last is 4. You could do the shortcut on that and it would work. Minus, and then I have to do FOIL on that, so it's going to give me x squared plus a negative 4x plus 3. Okay, then I would have to distribute my negative, so I would have x squared plus 4x plus 4 minus x squared plus 4x minus 3. And then on the bottom I still have x minus 1 and x plus 1. The x squares go away. The 4x plus 4x is 8x. And then 4 minus 3 is plus 1. So then I have an x minus 1, x plus 1, and there's nothing else I can do there. Now, these look a little weird, because what you're going to have to do is you're going to have to come up with a common denominator on the top, and then a common denominator on the bottom, and then divide them. So if you look on the top, there's an understood 1 here. So the common denominator is actually going to be 3. So I'm going to multiply this one by 3. So I have 3x, and then that one just stays as an x. Okay, so now I do the bottom one. This is over 1, so the common denominator is 6. This one I would have to multiply the top and the bottom by 6. So I have a 6x minus x. So when I bring that down here, I have a 4x over 3, that's this one, divided by 5x over 6. Well, you know the rules for fractions. You keep, you change, you flip. So I have a 4x over 3 times a 6 over 5x. The x's go away, and I can take the 6 and the 3, and that reduces down to a 2 over 1. So that's going to give me an 8 over a 5, or a 1 3/5. Okay. All right. One more, maybe two more. We got two more to do, and these are the longer ones. Okay, if I look at the top, I have to come up with a common denominator. This is underneath 1, so my common denominator on the top is going to be xy. It's going to be the combination of that and that. So this one is missing an x. This one is missing an xy. And this one is missing a y. So that's going to give me a 2x squared plus xy minus y squared. And then on the bottom, again, the common denominator is xy. This one is missing an x. This one is missing a y. And this one is missing both an x and a y. So that gives me a 2x squared plus, that's a y right there, plus a y squared minus a 3xy. Okay, so then I'm dividing. So I have a 2x squared plus xy minus y squared over xy divided by 2x squared minus 3xy plus y squared over xy. So I'm going to invert and multiply. Okay, so and I'm going to go ahead and see if I can factor these. Let's see, a 2x and an x and a y and a y. And if this one is positive and this one is negative, it would factor into that. So it's over xy. I'm going to flip this. The xy comes on the top, and I'm going to see if I can factor that. So I have a 2x and an x and a y and a y. And if they're both negative, it gives me that. So that goes away, that goes away, and I'm left with x plus y over x minus y. Okay, these are intense problems. All right, last one. All right, the only thing we can factor here is that one. So I have an x over x minus y plus a y over, that's going to be the difference of squares, so that's x plus or y plus x and y minus x. And this one is x plus y. Now you'll notice if I were to factor out a negative here, it would match up with that one. So that's what I'm going to do. So when I factor out a negative, it's actually going to go to the top, and I'm going to change this becomes a positive y minus x. And I did that so that it would match up with there. So you see that this is a combination of everything. So my common denominator is a y plus x times a y minus x. So this one is going to be missing a y plus x. This one is not missing anything. And this one is missing a y minus x. So there I've got a negative xy minus x squared, then plus y, the next one, plus a 2xy minus a 2x squared. Alright, so I have got, if I combine anything together, I've got a negative 3x squared, which is there and there, and then I can combine those two, so a positive xy, and then plus y. and that's over y plus x and y minus x. And you can't do anything else to it. Okay, you can't factor that, so that's your final answer. Okay, the homework is page 573, 20 through 38 even.